Welcome back. Last lesson I started working on maximum minimum without realizing I hadn't taught you tangents and normals. So I had to spend a lesson going over tangents and normals. So we are now on to stationary points. Remember, y equal to fx. Y keeps on varying as x varies, and dy by dx is the rate of change of y with respect to x for very small changes in x. What happens? What do you mean by saying stationary? Meaning y becomes stationary. That means for a split second, for a fraction of a second in terms of time, or for a very specific value of x, the rate of change of y with respect to x. Look, if I am stationary, I am not moving, so my speed is 0. So ds by dt is 0. So the concept of stationary means the gradient becomes 0. If the gradient is 0, a line with gradient 0 is a line parallel to x-axis. So at a stationary point, the tangent is parallel to x-axis. So let's look at this curve. Suppose I have a curve like this. At this point, the tangent, let me make this boom, yeah. The tangent is parallel to x-axis. At this point, the tangent is parallel to x-axis. At this point, the tangent is parallel to x-axis. So you have 3 stationary points. I don't want to go into inflection as yet. I'll come to that later. So now this is a cup, meaning just before the stationary value, the gradient is decreasing or negative. Immediately after the stationary value, the gradient is the gradient is positive. That means the curve is increasing. So you come down, come to rest, and go up. Then that's a minimum point. Similarly here, you're going up, come to rest, start coming down. That's a maximum point and a minimum point. So in other words, if you want to find the stationary points on a curve, you use the fact that the gradient at that particular point is 0. That means gradient is dy by dx or f dash of x. So put f dash of x equal to 0 to find stationary points on a graph. But then you have to decide whether it's a minimum or a maximum. Yeah? In which case, what you do is you take a small value to the left of the stationary value and a value to the right of the stationary value. See how the curve is changing. It's negative to positive is a minimum point. Positive to negative is a maximum point. Yeah? Let's take, in other words, let me put all those things. So in other words, for any stationary point, dy by dx equal to 0. Okay. Now, if for example, at x equal to k, dy by dx is 0 and y is, let's say, p, then this where students again are not very clear as what they're talking. X equal to k is not a stationary value. X equal to k gives the stationary value, and the stationary value is y equal to p. Please don't say x equal to k is a stationary point. No. X equal to k gives the stationary value or makes the graph pause maximum or minimum, or later on we'll see inflection. And then y is equal to p is the stationary value. So whenever you find maximum and minimum, it's not the value of x that is the maximum, it's not the value of x that is the minimum. It is the value of y and not x. Please don't make that mistake. So in other words, at x equal to k, y is stationary. And stationary value is p. Okay? So now, and to find maximum minimum, you take a value to the left, take a value to the right, and then decide. How to keep an eye on the clock. As I said, these things will be in your handout, so you don't have to copy this. But for the moment, I'll leave it there. For example, let's say find the stationary points on the curve y equal to 4x cube minus 3x squared minus 6x plus 4, and determine their nature. Okay. So what we do is find dy by dx is 12x squared minus 6x minus 6. Dy by dx must be 0. So equate it to 0. So I can say I can divide through by 6. Again, I told you in the exam. In the exam, if you don't divide by 6, you are expected to factorize that. So it's 2x squared minus x minus 1 equal to 0. So 2x and x minus 1 plus 1 equal to 0. So I get x equal to minus half, x equal to 1. Please don't, if you don't write this and write this directly, you lose a method mark and you just get one sympathy mark for your correct answers. So correct method is, if you want to factorize this, please factorize it correctly. So it is 12x and then x, I want minus 6x, so minus 1 plus 6 equal to 0. Then you say x is minus half. So if you want to factorize that, that's the way you do it, or you write this and factorize this way. Please don't write this and then this. You will lose the mark. Or write this and write that. Either way you lose the mark. Okay. So x is minus half. What is y? 4 times minus half cube minus 3 times minus half squared minus 6 times minus half plus 4. Half cube is 8. So minus 4 over 8 plus minus 3 over 4 plus 3 plus 4. 4 over 8 is half. Don't straight away take a calculator. Use your brains. 4 plus 3 is 7. Okay. 4 over 8 is half. Half and 3 quarters is 1 and a quarter. 1 and a quarter take away 7 is 5 and 3 quarters. Use your calculator. So it is 5 and 3 quarters, 23 over 4. So you know one stationary point is minus half and 23 over 4. Let me write that here. And the other one, put x equal to 1. 4 minus 3 is 1. 1 minus 6 is minus 5. Minus 5 plus 4 is minus 1. 1 and minus 1. I did it orally. X equal to 1. Y equal to 4 minus 3 minus 6 plus 4. 8 minus 9 is minus 1. Why did I do that? So I can get rid of this. So I have found the coordinates of the stationary point. But the question says determine their nature. Are they maximum? Are they minimum? Yeah. So therefore, what you'll do is determine nature, I will use gradients. Always make a table x, dy by dx and sketch. I find this easier. What the first, for each one of them, make 3 columns. Put the stationary value, stationary value of and the point, the value of x where it is stationary in the middle. Take a value close to it on the left and on the right. Please don't blindly add 1 or 2 because in this case it works. What if one stationary point is 1.1, another one was 1.5? When you want to take values close, don't start with minus 240 and plus 271. Close values. So very close to minus half is minus 1 and 0. When x is minus 1, what is dy by dx? 12 plus 6, 18 minus 6. Positive. If dy by dx is positive, the graph is increasing. At that point, it is 0. So the graph, the tangent is horizontal. At 0, the gradient is negative. That means the tangent, the gradient is negative. That means the tangent as a negative gradient of the curve is decreasing. Now, what is this shape? It's a maximum point. It's a local maximum or a relative maximum point. Okay. Now, do the same thing now for the other value. In fact, I could have continued there only. I purposely did it separately because, what if another question, there is an asymptote, you'll get into a mess. So, safer to do each one separately. The other value of x equal to 1 is a stationary value. Less than that is 0. More than that is 2. At 0, dy by dx is negative. So, the graph is decreasing. At 1, it is 0. So, the graph is horizontal. Tangent is horizontal. Or the value is stationary. And at 2, 24, 48. Positive. So, it's increasing. Look, decreasing, 0, increasing is a tub or a cup, which is a minimum. That is how you find maximum and minimum values. Okay. I'll take a simple example to illustrate a pitfall which you come across. I'll take 2 examples. Y equal to 2x cube minus 3 and then y equal to 2x power 4 minus 3. The only difference is 1x. Find the stationary points and their nature. Okay, so what's dy by dx? Is 6x squared. Equate it to 0, x equal to 0. When x is 0, y is minus 3. Let's see here. Dy by dx is equal to 8x cube equated to 0, x is 0, y is minus 3. Now, another way of finding which your teachers have taught you, what I'll do is, I think I'll do it this way and then discuss that as well. So, one other way of finding maximum or minimum is by finding the second derivative. That means differentiate it again. But when you differentiate it again, do not equate it to 0. Whatever value of x you have got, you put it into your expression for d squared over dx squared. If it is negative, that means the graph, as soon as it cuts the turning point, the gradient is changing from positive to negative. That means the rate of change of gradient is negative. It was positive, is turning into negative, then it's a maximum point. If you took a minimum point, the rate at which the gradient changes, it goes from negative to positive. So therefore, the rate of change of gradient is positive, so it's a minimum point. Okay. So I will do it that way. D squared y by dx squared is 12x. At x equal to 0, d squared y by dx squared is 0. Whoops! I just now said if it is positive, it is minimum. If it is negative, it is maximum. But it is 0. And immediate, oh, yes. Sir, it's inflection. It is inflection. So, according to you, that's a point of inflection. What is a point of inflection? I'll come to a bit towards the end of this question. Let's look at this. What is d squared y by dx squared? Is 24x squared. At x equal to 0, d squared y by dx squared also happens. Therefore, sir, simple. So that's inflection, that is inflection. Let's try the gradient method. So what are the value x, dy by dx, and sketch? Remember I taught you in the last example. Oh, I have 16 minutes, I'm safe. Okay. At 0, take a value, minus 1, take a value 1. At minus 1, dy by dx is positive. 0 at 1, it is positive. That's increasing, like that. So if you have on the graph, let's say this is minus 1, that is 0, that is 1, the gradient is positive, the gradient is 0, sir, I told you, sir, it's an inflection. Why don't you believe me? I believe you. Let's try here. X, dy by dx, and sketch. Same values. I am not taking a different value. This is 0, 1 and minus 1. At minus 1, what is dy by dx? Negative. At 0, 0. There, positive. What do you notice? So 0 minus 3 is minimum. In both cases, d squared by dx squared is 0. But in one case, it turned out to be a point of inflection, whereas in the other case, it turned out to be a plateau. Point of inflection is a plateau. The curve is increasing, momentarily becomes horizontal and again increases again. Yeah? And there, it's a minimum point. So, what do we learn from this? The test using d squared y by dx squared fails when d squared y by dx squared becomes 0. In that case, you have to use a gradient table to decide maximum or minimum or inflection. Don't blindly assume that just because d squared y by dx squared is 0, it is always an inflection. I think later on, it's not, I don't think it is in your syllabus, but I will discuss in short, the conditions for inflection in the next lesson, okay? So, I'll take more examples to show you. So, what I want to do, therefore, to recollect, to find stationary points, find dy by dx, equate it to 0. Number 1. Number 2, find x, find the corresponding value of y. So, you get the coordinates of the point. Unless they say find the x coordinate only. Next, you do second derivative, because that's the easiest way. Second derivative, put the value of x you got, don't equate second derivative to 0. You cannot, if you equate it, you are going somewhere else. You're going to point of inflection. Actually, a point of inflection is defined as second derivative is 0 and the rate of change of gradient to from left to right always changes sign, then it is a point of inflection. That's what I wanted to talk to you about, which I'll do in the next lesson. So if d squared by dx squared is 0, do not assume it's a point. So number 1, do not put d squared by dx squared equal to 0. Whatever expression you have as d squared by dx squared, put the values of x you got into that. If you get a positive answer, The stationary point is a minimum point, the y value is a minimum value. And if your answer is negative, then the point you got is a maximum point, meaning the stationary value y is a maximum and the maximum value is that of y. But if d squared y by dx squared is 0, safest would be do not assume that it is going to be a point of inflection. Always test using gradients. In other words, a gradient method is a sure shot way of testing for maximum minimum. Second derivative works in most of the cases except when that becomes 0. Keep that in mind and don't have to worry about it. As I said, it will be in the handout. Have a nice day. Bye-bye. Hello. I want to take this opportunity to propose a vote of thanks. I would like to thank Vivid Innovations Private Limited and Commerce Forum for so generously giving up their studio and the facilities and the services of their technicians to record all these videos for free. I think that needs to be acknowledged and appreciated. Thank you very much. And my special thanks to Mr. Nitin Mahadevappa, Mr. Nishant Guruswamy, and Mr. Sadan Kumar DN for all their help and assistance in getting these videos ready, uploaded, and launched. Thank you very much.